You know, I wouldn't expect Vidley, of all places, to be very receptive to my message, but I'm glad because I get to redeem Vidley of a little bit of its absolute trashness.
Where is the urine stored?
Hey, so
You can find more about that on my other channel, but I'm glad you guys are sticking around because I just love educating people, I guess. So for you to be there and listen to what I have to say, that's pretty good. And I know I've been kind of lax on the uploads lately. Last one I've done was October 2nd. But new ones should be coming soon whenever I find the time. Because I haven't had as much time as I've had during July and August to do this, but I hope to do it more soon.
Steam takes up about 1,000 times more volume than liquid water. If you have liquid water at 300 degrees Celsius and suddenly you depressurize it, it doesn't stay liquid for very long. It flashes into steam.
When you put water under extreme pressure, like anything else, it wants to get out of that extreme pressure.
3 Mile Island, Chernobyl, and Fukushima were all radically different incidents. But what all three had in common was how poorly water performed as a coolant when things started to go wrong. These three accidents illustrate the need for a coolant with a higher boiling point than water.
You see, I had the good fortune to learn about a different form of nuclear power that doesn't have all these problems for a very simple reason. It's not based on water cooling and it doesn't use solid fuel. Surprisingly, it's based on salt.
Nuclear fuel can be liquid. Is liquid fuel really that hard to work with?
I have a friend I've made online who is a nuclear reactor operator, and he goes, I'm always fighting xenon in my reactor. That's like all we do as operators is try to deal with this stuff. And it's really hard to deal with in solid fuel reactors. Xenon is a gas. What happens to gases in a liquid? They come right out of solution.
To compete with thorium breeding levels of efficiency, a uranium-fueled reactor would need to overcome some additional challenges. But even the incremental improvements possible by using similar molten salt reactors fueled with uranium would allow us to extract additional energy from our existing stockpiles of spent fuel. Unlike today's solid fuel reactors, which can only be economically fueled with uranium, it is possible to fuel an appropriately designed molten salt reactor economically with thorium.
I started out at the lab in 1957 and got onto the molten salt reactor experiment. The dynamics were not common to reactors because it was molten salt instead of water-cooled solid fuel. If it heats up, it gets less dense, and that means it's less critical.
Or less reactive.
Yeah, less reactive.
Yeah.